Okay, let's start our today's lecture. I'll create another scene, lecture 6. Create a new object here, cube. And what we'll make with that object, let's try to rotate this object by our mouse input, for example. We wanna rotate it in this direction and also in this direction. So how can we make it? I'll create another script. Lecture 6. Open it. So we'll rotate our object with a certain speed. So I'll create a public float variable speed, rotation speed, float. And we'll write a function. What we'll do when we hold our mouse button and drag it. So what I'll write, void on mouse drag, and this function will detect our mouse button when we hold it and move it. So what we are doing on dragging mouse. So first of all, let's make the rotation around this y-axis, which is the horizontal direction. So I will drag my mouse in this direction, and our cube will rotate accordingly. So I'll create a new type of variable, float y, and detect these movements around the y-axis. For this, I also need to get axis, as we did on the previous lecture. File, build setting, and I need to find axes. No. Layer settings, then input manager, and mouse y. It will correspond to the dragging mouse in the horizontal direction. So I need to copy this name, as Unity has some predefined axes. For example, in previous, for camera zoom, we used the mouse scroll wheel. So we use this name and we get access to the scroll wheel. For example, we also try to work with the mouse button. Instead of defining get mouse button, we simply use this fire, and it also corresponds to the mouse button. Here we will work with the mouse drag, so we will use this name, mouse X. So I will copy this name and we'll use it here. Get axis mouse Y for the y-axis, and then we need to multiply it by our speed, road speed. So inside this variable we get the value of how far we are dragging our mouse and multiply it by our speed. And next we need to transform our game object cube by this value. Rotate and choose axis around which we want to rotate. Vector 3. And here we can see some explanations. For example, if I choose vector dot right, it means that here inside brackets will rotate around this x axis. So let's try to choose this one, and then we need to define this value. Let's save it. And try to test it. First of all, need to give some rotation speed here, and then it's moving in a not direction I wanted to move to. So let's try to use another one. For example, here we can up. Yeah, up it will be the Y, so probably this one will move our cube to around y-axis. So let's try again. So now I'm dragging my mouse button, but it moves to the opposite direction. I drag mouse button to this side and it moves to the opposite side. So how we can fix it? For example, we can probably fix it by placing opposite sign here, minus y, and let's try again. So now if I drag my mouse button, cube rotates to this direction, and if I drag it to the opposite side, it's also drags. So that's how we can rotate our cube around y-axis. And let's also add some rotation around another axis, which is the, for example, x-axis. So I'll write float x equal to Here we'll write text and transform dot rotate vector 3 dot right. Now we'll use right as we wanna rotate our object around x-axis. So let's test this one as well. I'll comment this one out and test only this one. It's also opposite direction, so I need to add minus sign. And probably I need to switch axes. So let's try it one more time, again one by one. Here I'll try to write y. Yeah, now it works better, and also for the x here. So now we can rotate our cube in any direction. So again, how we made it: first of all, we defined a public float variable by which we rotate our object. Then we used function which detects our mouse dragging, and then we used axes defined by Unity, which in charge for the getting mouse dragging in horizontal and vertical direction. And then we multiply this value by our rotation speed, and then we rotate our object by this dragging. So again, in order to find name of these axes, you need to go to the project settings, player, the player input manager, and here you will see the names of all predefined axes. Previously we didn't work with the user interface with some buttons, so let's try to work with some buttons now. For example, I will create a button UI button, and here's the button appeared. For example, by clicking this button I want to change color of the cube. So how to make it? Inside the script I'll create a new function, public void change color. First of all, I'll create a public game object, and we'll attach our cube later to it. So public game object cube, and by this function we'll change color of the cube. And get component. First of all, in order to change color, we need to write get component, get access to the renderer, then to the material, color equal to color red. So we created a function. This function will change color of our object, which will attach to this public variable game object cube. Then I will get access to the renderer, material, color, and change color of it. So now how to attach this function to the button. The button here has some on-click events, so we can attach our function to this place. First of all, we need to click plus button, and then you need to place object with your script. We firstly attach our script to the cube. Here we need to place our public game object. Actually, this script belongs to the game object. We are working this, so it's not necessary was to define this public variable. We could simply write get component renderer. Okay. So for example, here we have our script, and then in order to provide some function, we first of all need to place here object with the script. So we attach our cube to this place, and then we will be able to choose a function which will change our color. So here we go to the corresponding script, lecture 6, and here I choose the corresponding function change color. And this function should be public, otherwise it won't be able to find it here. It won't appear here if it will be private, so it should be public. So now let's try to click this button and check whether color will be changed or not. Now I'll click it and color was changed to the red. So that the simple way of working with the button. So you create public function which makes something, then here you go to the button, on click plus button, so you can add as many functions as you want. So this button click can cause certain function which will be called at the same time, so you can add as many as you wish. And then you need to attach game object with the script and choose function you want to work with this, change color in our case. Next, let's consider some more details about the user interface. For example, when I created a button, the button automatically was created a canvas, and on the canvas, it's a really big place For example, when we work with the canvas, we can switch to the 2D mode, so it will be more easy to operate with it. So on our canvas, we can locate our buttons and other user interface. For example, we can create panel here. Panel. We can change its color to any other color. And on this panel, we can locate our buttons, for example. And for example, I'll create slider. And we can locate this panel somehow. For example, if I will change, you can see that if I change size of the screen, size of the canvas is also changing because it's defined by our screen. So this also need to take into consideration. For example, if you make your program for a specific screen, it probably won't be able to start it on another screen. For example, it has a different resolution, and for example, button won't appear if you have a different resolution. So you need to also take it into consideration while developing your programs. So because of the screen, size of some elements can be changed. For example, here choose specific resolution 1920 by 1080. Then you choose another resolution, and you can see that your elements appear different. So what we can do here is to use something is called Rect Transform. For example, if I currently, as you can see, it's stretched for the whole screen, but if I attach it to a certain position, for example, if I will fix it on the right side, so our panel will be fixed on the right side. So now if I will change screen resolution, you can see that works better than before, but we need to also do the same with the buttons and sliders. We need to fix them somewhere. For example, panel with somewhere. And currently our panel is bigger than our canvas, so what we can do here is to stretch it somehow. So we need to click Alt plus Shift and then select stretching and attaching, so it will be scaled according to our canvas. So then what we can do here, we can, for example, define some spaces here, -10 from top, 10 bottom 10, so it will looks a bit better here. And then I will locate these elements here somehow. So now our panel is attached to the right side of the screen, and this button and slider, they center it according to the panel. So now let's try. You can see that panel is constant according to this side, but button and slider, they go away. So we need to also fix it somehow. What we can do is also select, for example, center it according to this side, to the right side, and similar for the slider and similar for the button. Now try again. No, again, no luck. Then try to not this one. Let me create one more button. And try it one more time. So if these problems appear, for example, we can do it in another way, but actually it should work fine. I don't know why it's happening here. Let's try one more time. For example, currently slider in the right place, but buttons in the wrong place. So we can attach these buttons to the left side, right side corner, for example, to this place. And now if we change size, all elements on our panel. So we finally managed to make that. Next, what we can do here, for example, our slider has some values defined here, and we can modify value of our slider currently from 0 to 1, but we can change it to any other number, for example from 0 to 100, and then these values will be changed from 0 to 100 or from 10 to 100. And how to work with the slider, for example, let's write some function public. First of all, we need to add a public slider. And it will be highlighted in red, because first of all we need to add corresponding namespace, corresponding library using Unity engine .ui. So when you're working with the UI elements, you need to add corresponding library. Then you will be able to create, for example, slider, input fields, and so on. So next, let's write function public function public void print slider. Wow. And here what we need to write, print slider value to the console. Print slider value to string. So when we will call this function, it will get current value. It's between the range from 10 to 100. It will convert it to the string and print it to the console. So again, let's find this script. This script is attached to our cube. Here we have public variable slider. We will attach our slider to this public variable, and then we'll, by this button click, again we attach this cube object, select our functions, slider, print slider val. So now if we'll click button, the color will be changed of our cube, and here we'll print value of the slider, current value. So let's try to test. So currently it's 10 minimal value. Let's try to change it. 100 maximum value, somewhere in the middle. 58. So that's how we can work with the slider. So what else this slider has? For example, background of the slider can be changed to any other background. Fill area, there's game object, here we have fill. So color, the color I think when we move our slider. Oh yeah, that's when we move it, it will be another color. So that can be changed by fill. And then again empty game object, and then the source image of our slider. For example, it also can be changed to any other. So that's how the slider can be adjusted. And for the button, for example, we can change button text. Right, button 1. Then its size can be changed. Then we can center it where we wish. So now let's I want to talk a bit about canvas itself. There are different types of canvas. For example, the first one, screen space overlay. This is this canvas. It is up to the screen size, so it's really big. Our cube here, and canvas is here. It has so big size because it has because of the pixels. For example, choose this resolution. So canvas depends on pixels, and it's rendering everything in 2D. For example, if I'll try to rotate this panel somehow, here it won't be any changes. So for example, let's compare it. Here you can see that it's kind of looks like 3D when I rotated my panel, but here it's the same. So the screen space overlay canvas, it's rendering everything in 2D mode. So currently it should be the perspective projection, but it's wrong. So it's a limitation of this type of canvas. So you can't get a proper perspective projection. So in order to get it, you need to choose another type of canvas. For example, if I will change Z-axis, you can see that depth also changing, but in the orthographic mode everything is scaled similarly, so we can't work with the depth by this type of canvas. So in order to get some different behavior, we need to switch to another type of canvas. For example, I'll copy this thing. And another type of canvas is called screen space camera. And here you need to choose the camera. So, but the benefit of this canvas is that, first of all, let's try to attach it to the camera. Example, camera, and it's also scaled down now. It's because currently it's belongs to the camera view, so that's why it was scaled down. But now you can see that perspective projections is working correctly. So we can rotate our panel and we'll see corresponding response. So on our canvas it's also the perspective projection, which is a good thing. And also, for example, if I will move it backward, it will be also moving backward, and so it's also up to depth, which is also a good thing. But here what the problem is that you can see that this game object cube is currently superimposed on our panel, but we didn't have it before with a different type of canvas, which is a screen space overlay, because our game object is behind the panel. and with a new type of canvas, screen space camera. Here we have our game object. For example, if our button will be located here, we probably won't be able to click it because of this cube. So how can we fix it with that type of canvas? For example, here there is a value plane distance which can be modified, but there is another way. For example, we can create another camera. So create camera, remove audio listener. So I don't need it for another camera, so I'll remove it. And now I will attach this camera to our canvas. So currently it observes only UI. But we need to remove our game object somehow. So how can we make that? Camera, cooling mask. First of all, we can select here depth only. First of all, it was skybox, but if we select depth only, we'll be able to see the game object as well. And next, what we need to do is to here select nothing and UI. Now it will be rendered correctly. Now our cube is behind the panel, it won't disturb us, and now our panel in the right place and it's viewed from the another camera, so that's how we fixed it. So next type of the canvas is a world space. What is a world space canvas? For example, I'll copy one more and select here world space. Okay, I better create a new one. UI, I'll copy from here. Okay, but a new one. Create UI canvas world space. So what we can do with that world space canvas, it means that we can locate it somewhere in our scene. For example, I will add some text here. Student. I'll pin it by clicking Alt plus Shift at the top. So now I can play with the scale of my canvas. And what I will try to do is to attach this canvas to our cube on the scene. I'll scale it down. Canvas cube. So create panel. Also by these tools we can change the size as well. You can manipulate with the transformations, rotations, scale, and this size by this panel. And for example, I can add here also button, also slider, so now you will be able to manipulate by these elements in the world space. For example, you will be able to create some kind of terminals, and then inside the program you will be able to click these elements. For example, they will be interactable inside the scene. So here you can click this button, modify slider. For example, let's make something. Here we have a script, slider, cube. For example, I will try to attach it to this script to another object, and we'll attach this world space slider to the game object. Slider, add it to the button, select function, slider val, and let's try to test it. So now I'm changing the value. I didn't modify this slider, so the value here is from 0 to 1. And as you can see, they're printed inside the console. So this is the default values, no 0, 1, and here's the world space. And you can create as many types of these canvases as you wish. Locate them in a different place, for example. And also this type of canvases will work as well. So you can have this one, world one, different types. So these are 3 types of canvases. Screen space overlay, it only works with a 2D. Then another one, camera, and another one, world space canvas. So what else this user interface has, for example, it has images, UI image. So here image has several functions. For example, we can select some default sprite, this one, and then we're able to get access to different image types. For example, this one, tiled, it will create an array of images along this size of the image. So you can create some background behaviors, background textures by just cloning so what else? Field, here you can create some types of animations, for example, radial, horizontal, and modify this value. And what is the slice? Let's consider what is the slice. For example, I will add another image, create new folder, images, and attach a new image. For example, frame. So in order to be able to work with that frame, I just simply found this frame on the internet and downloaded its PNG. So any image can be taken from the internet. So in order to operate with it with the UI, first of all you need to change type of the image. So here it's currently default, but in order to operate with the UI correctly, you need to choose Sprite 2D and UI. So you select this one and then you can choose the resolution. For example, you can scale down and then apply. So now you will be able to operate with that image here. Here you can use preserve aspect. It means that if you scale it, it will be the similar size, so it won't be distorted. If you unclick it, it will be distorted. So you can see that you are changing the size and distortion appears. So what you can do inside the Unity, another way, instead of using this preserve aspect function, you can do it in another way. For example, you can edit it by Sprite Editor. So you need to click it, and here no sprite window register. So if you got a similar message, first of all you need to download this 2D Sprite package from Package Manager. So how to make that? You need to open Package Manager, and here you need to search for 2D Sprite Editor and then install it. So let's try to open it again, and now Sprite Editor was opened. Here we can move this border, green border, to the inner part of the frame. And what this means, that only this inner part will be changeable, and if we scale this, what is out of the inner, it won't be changed. So I will save it, apply it, and let's see how will it work. Our image, so probably image type not sliced. I don't know, are there any difference between the previous one and this one, but it should be. Let me probably try with another image. Maybe with another image it will be more clear. So again, I need to select Sprite 2D and UI, apply, and create another image here, and attach this panel. Now I'll try to, and here it's also seen it's distorted. Let's try to, and if I choose preserve aspect, it won't be distorted. Let's try to make it another way. Open Sprite Editor and move this border inside. Apply, close, and let's try to modify it. Again, maybe, yeah, it should be sliced, yeah. So that's the thing. Now I'm changing the size, and this frame is constant. So if you choose slice, everything is work fine. About this one, simple sliced. Yeah, it's also probably constant. Okay. And next, I'll show you how you can store several elements on a panel. For example, if you created many buttons on your panel, for example, you can sort them by adding component, choose panel, adding component, and here you need to search for layout element group. So we can select horizontal layout group, vertical layout group. For example, if I will choose horizontal, or if I choose grid layout group, it will sort my elements this way, in a grid way. Here you can select some parameters, where to center them, for example, inside in the middle. Play with the size, spacing between them. For example, another group, horizontal layout group. They will be centered horizontally. Also, you can select where to center. So modify space and other parameters, or vertical layout group. They will be centered vertically. And here also can make some adjustments.